All right, everybody. Thanks so much for the opportunity. I think it's the first time I've been invited to speak in London for a local meetup, and I really appreciate it. I like helping people, and it doesn't actually matter how big the size of the help is to me. And as soon as I hit this thing, I'm Bryan Finster. I work for a very large retailer in Northwest Arkansas. And I've been a software developer for longer than I care to admit. I'll just say over 2 decades. I also have been focusing on how do we actually execute continuous delivery since 2014. There's a area of the company I was from supply chain where we're trying to figure out how to take our quarterly delivered application and deliver it every 2 weeks. Ultimately, after some of us developers dug into it, we were able to get that to multiple times a day on several of the products that broke out of that big application. And then I moved up to platform to figure out how to scale that across the enterprise. How do we teach teams how to actually execute continuous delivery? And it says value stream architect here. This is a role that Mick Kirsten has proposed as an emerging role in the enterprise, where it's how do we analyze the entire flow of value through the enterprise and remove waste, improve the flow, and deliver value better. And I lead the DevOps Dojo. We started up a couple years ago. There's, you may not be aware, there's a lot of enterprise dojos starting at Target, rolling out through Verizon and Capital One and several other enterprises, both here and several in the UK I'm aware of. From DevOps Enterprise Summit. And that's what we do. We specialize in the technical coaching around how to deliver value better. So I always start this with why CD. I think a lot of people don't really grasp the reality of why CD. I've experienced a lot of pain from not delivering with continuous delivery. So this reflects some of my experiences. So hopefully it speaks to you. Before continuous delivery, we had legacy delivery. And what we did was we go and get a business requirements document and put a project plan together, and then just go and build everything to the specification. And when we were done, we'd hand it off to the testing team to go off and test it. And of course, everything was perfect until it wasn't. And then we can go and fix things and everything would be fine. And then we'd take that giant batch of work and we'd go and deliver it, because that's the most efficient thing to do. And then we go into the war room for days or weeks or months and fix all of the breaks. At which point, the executives would call us in and blame us and inspire some fear and mistrust and tell us that failure is not an option. And I've done this repeatedly. And the problem is that failure is a promise. So why do we fail? Well, the reason we fail and the reason that we're building an entire flow of delivery this way is because of these reasons right here. The requirements are wrong, or we misunderstood them, or they're going to change before we can deliver. And this is the reality. People talk about the agile mindset, and none of that made any sense to me at all until I started really digging into CD, really digging into why are we doing this thing anyway? And once I started delivering this way and I was able to mitigate these, this is what it came down to me. This is the agile mindset. So like I said, failure is absolutely a promise. The thing that is optional is preparing for failure. And that's the other thing that CD does. CD is not about feature delivery. CD is about the ability to build a safe flow that allows us to fix production rapidly. And it's about production stability. And the way that we know that we can do that is by delivering daily and verifying that we can fix production when it breaks, because it will. And keeping those changes small, so when it breaks, we fail small. So the very first thing that people do, right, it's like, we're going to do continuous delivery. So they go and implement Jenkins, they automate the build, and they say, we're doing continuous delivery. I cannot tell you how many times I've had teams say, well, we're doing CD, except for all this other stuff, but we've got a build pipeline. But things aren't improving, so CD is probably not going to work. But fact is that CD is not tools. It's the way we operate. It involves every single step in the process from idea all the way to production and in operations. I have a really hard time separating CD and DevOps. They're basically the same thing, except that CD I look at as implementation. So what does CD give us? Well, it gives us faster feedback, and that's really the goal, right? We want feedback as rapidly as possible to how wrong the requirements are, how badly we misunderstood them, or if they're actually still needed, so that we can adjust. It also gives us sooner, safer value delivery. If you've not read Jonathan Smart's latest book, or his first book, that just released a couple weeks ago, Sooner, Safer, Happier, I recommend it. He goes into why it's a more humane way of working. From my perspective as a developer, and from my team's perspective, we don't do this job because we were hired to do this job. We were doing this job before it was our job as an extra job we were doing anyway, because we knew that working this way made it better for the team. You wound up with a team that had higher morale, more pride in their work. They were able to iterate rapidly and generate a lot of good teamwork and better outcomes. And we are after that more humane way of working because it helps both us and the company's bottom line. So we're super passionate about it, and we'll help anybody who wants to do it, and we'll point and laugh at any manager who doesn't. So given all that, what we've come to see from not just my team, but the Dojo consortium as a whole, when I've gone and talked to them to compare notes, that we see a few common things that are that if we can just fix these things, teams are well on their way to CD, and then all they have to do is tune up. So what are those main challenges, right? What are the things that are killing us? Well, number one, it's we have a leaky pipeline. They'll go and lay out a pipeline to get from commit to production or at some point close to production. But the processes are not aligned with CD. If you're using a CD flow, once you commit code, there are no human touches after that. And so they'll have handoffs. They'll have handoffs to a testing team, or they'll have handoffs for change approval, or they'll have all these external handoffs that are outside the pipeline. And the pipeline is supposed to be those things. They'll have hotfix exception flows. Talking about branching a few minutes ago, they'll ask, well, how do I do a hotfix branch? You don't do a hotfix branch. Or they'll have manual processes. Again, you're supposed to have no manual processes after you commit code to master. What we're looking for is one path to deliver, one way to get it done, to get feedback as rapidly as possible to the outcomes of what we have done. Hang on, my slide. Oh, I'm sorry. I haven't given this deck in a few weeks. But the feedback loop is only part of the problem. I'm part of the solution. That's not CD. It's the automation that gets us there, but it's the very first step, and it's the highest priority. But we have to figure out how to use it effectively. The feedback, the pipeline, the automation, what it does is it reduces the cost of change. It allows us to take all the manual toil that we were doing and automate that. And so that means that we can deliver smaller batches. And the smaller batches are where the secret is, because every haystack has needles in it. And smaller batches make it easier to find the needles. And ultimately, if you get down to the point where you're delivering something so small that it's just one piece of straw, there's no needle there, that'd be awesome. If we can get there, but smaller batch is good. It also reduces waste and toil. The smaller batches, if we drive down the size of stories, if we drive down the size of the commits, we drive down everything, you start uncovering process overhead or issues with testing or teamwork issues or things in the team. And removing that, you can find and remove that waste. And of course, the automation means that I don't have to pay somebody to do what a robot can do. I can pay somebody to do something smart. All of this works great, but only if we make small changes. So we've got our pipeline, we've understand what our goal is, but we're still making changes with stories that are like 2 weeks long and waiting to merge complete things. It's like, I'm going to go and create a feature branch. I'm going to complete the entire feature, and I'm going to go integrate the feature branch, and I'm going to do eventual integration. But continuous delivery depends on continuous integration. And that's the primary quality process we have is CI. So again, large batches, you're going to have more defects in large batches, and waiting for feature complete is the very first problem that we have to overcome, that mental block. And teaching people how to code so that they don't have to be feature complete to deliver. And getting developers past that mental block, it actually doesn't take time take a lot of time when you focus on it. We're talking weeks, not months. But giving that a problem to solve is key. Heavy code review process increases batch size. When I talk about heavy code review process, I'm saying pair programming is awesome if we're using a branch and pull process where code review takes us like 10 minutes. So we're focusing on the important things. Are the tests correct? Is the code communicating intent? And really driving to those important things at a code review versus we're going to have a formal code review with a whole bunch of people, or we're going to have multiple code reviews because, well, the seniors got a code review it too. It can't just be that other guy. The heavy code review process increases batch size. Larger batch, more defects. External approvals, the same thing. You can see a thread here. We're increasing the cost of delivery. External approvals mean that every delivery costs me more to do, so I want to make sure every delivery is bigger to get the most bang for my buck. So what we do is we try to remove those external approvals. And ineffective or manual testing. So driving towards code coverage instead of effective testing, depending on manual testing is really good for finding things like usability or tests we couldn't think of to test before, but it's not good for anything else. Costs too much money. Again, drives up batch size, especially if it's an external team. That's even worse because the external team, you've got another handoff there. The handoffs is additional waste, bigger batches of work. So the way that we find these and fix these, and the thing that we found most effective and the secret to all of this is focusing on CI as a behavior, not as automation, right? So the real rules of continuous integration is that we're going to integrate changes to trunk at least daily. And I said earlier, we use branch and pull as our trunk. You can do trunk-based development uses branch and pull. It's recommended from my perspective anyway, just for a compliance auditability point of view to verify that we've had two eyes on every change. It's a requirement for us. It might be a requirement for you. But that cadence of at least once a day, and preferably multiple times a day. On my team, it's generally 2 to 3 once we're up and running. And that change you made, you need to be 80% confident before you commit. I mean, these are the rules. Having a team focusing on these rules means that I have to make my testing much better. I can't just do some unit testing and then hope that some end-to-end test way down the pipeline executed by me or some other team is going to catch everything. The goal is that I'm releasable to production, or very confident I can be releasable to production before it leaves my desktop, and then the rest of the pipeline verifies everything else. And we want rapid feedback. I want to find out within minutes that I've got a break in the code. Now, this 10-minute number I give here, this is worst case. Best is 5 or less. Ultimately, what I'd like to know is before it leaves my desktop. But the CI build needs to give me that information as rapidly as possible that I'm broken, so that I can fix it before I context switch to something else and then have to context switch back. So doing this means that I have to go and that I will find all these problems, right? Well, the code review process is too heavy. Okay, so what do we have to do? What are we doing in code review? What things do we automate with static code analysis? What things do we automate with linting? What things are we doing that are just silly in code review? What are the value? I mean, this is the key, is that if we're moving to continuous delivery flow, then we're looking at everything we do, everything, not just the coding, everything from when something is thought of as an idea, everything down the line, and trying to identify, are we getting value from this thing that we're doing? And if we're not, then it's bad and we stop doing it. And if we are, can we automate it? And if we can't automate it, how do we make it the most efficient process we can? So given that, CI really depends on that 80% confidence before we commit. And then CD depends on 99% confidence, as much confidence as you can possibly get before we deploy. The problem that teams are going to run into, though, is they have terrible test architecture. And I'm not just talking about they don't have enough unit test coverage. That's not a thing I even focus on. It's that their entire test process is wrong. Because generally it looks like this. You'll see a team where they have some unit tests, but if they come especially from an area that's been doing waterfall and trying to transition, that they've got probably a lot of manual testing going on. The company's probably hired some external testers to come in and write a bunch of end-to-end tests to cover things. And then this is the pattern that just sticks. And you can't get feedback fast this way. In fact, the feedback you do get, especially from the end-to-end tests, are probably going to be feedback you can't depend on. They're non-deterministic. They'll fail for reasons that don't matter. And so this is the next thing we have to fix. We've laid out the pipeline. We focused on the CI behavior. Now we have to figure out how we get rapid feedback. So we focus heavily on how do we design an effective suite of tests, layers and layers and layers of tests, focusing on tests in the pipeline being incredibly deterministic. And we want them to make sure that if they fail for real. That if we have any test that's failing for reasons that are not related to a coding defect, that we remediate that test. We either pull it out of the pipeline because we only want deterministic tests in the flow, and then try to figure out why it's broken and put it back in. Or in the case of things like end-to-end tests that are stateful, that are going to be non-deterministic by their very nature, make them a parallel process, but only testing a thin set of functionality and not focusing on the main way we do regression testing to inform us if the tests we have in the flow are good. And the key thing is that if the team doesn't trust the test, the testing will fall apart. They'll see no value in maintaining it, and the test suite collapses, and then you have to start over again. So we have to terminate poor tests with extreme prejudice. And they have to execute quickly. I said, outside limit of 10 minutes for CI. For the entire pipeline, you're looking to be able to go from commit to production in less than an hour. And sometimes that means that you're uncovering architecture problems with your application, or even architecture problems with your teams, or the team structured correctly. But you need to resolve all those to be able to deliver quality. And they need to alert as early as possible. You hear about moving left. It's not just moving testing left, it's moving knowledge left. I need to know as early in the flow as I can that something's broken. Like I said before, if I can find it on my desktop, that's best case. Not only that, but if I break it on my desktop, then I'll learn from that and not break it that way again. If I only find out at a test that's running just before production, then that could be I could have context switched off to something else and might not even know that I broke it. Somebody else could have broke it. We don't learn anything. We just find something to fix, hopefully. And we just absolutely have to optimize for quality feedback. I mean, that's what we're doing. I was talking to someone earlier today about the fact that what we're doing is we're applying the Toyota production system to software development, but the difference is that all of our cars are different. Every one of them is unique. And so the only way we can tell what we're delivering to the end user is good is by giving it to the end user and finding out. That's how we identify quality issues. We can test for things that we think are quality issues, but we don't know the tests are right until we deliver it. And so we have to build an entire system of delivery around getting quality feedback, and that comes from the end user. And so there's blockers to that, right? We don't deliver fast enough. And this right here means that I'm not going to get feedback about my tests. I'm just going to keep writing tests, but I don't know if they're good tests. And also, testing is a secondary activity. We'll see issues where it's like, well, we're pushed to deliver the feature. We just don't have time to test. It doesn't matter if we deliver the feature because we don't know if it's going to work or not. If it does work, it's a complete accident. And the odds are we'll break it with the next change because we don't have a baseline of how it's supposed to behave to verify that we didn't break it. Testing is core to continuous delivery. It is no longer something that happens after. It happens during. You start testing when you start refining work. You start defining things a testable way. And it goes all the way through the flow as something that we breathe as atmosphere, not as an activity that happens at a stage. And like I said, flaky tests, those are going to block our feedback and they have to be killed. The poor test design, again, poor tests, they prevent us from getting that feedback and those have to be prioritized and fixed. But the thing that impacts testing the most isn't even just our knowledge of how to test. It's vague requirements. This is the number one thing that we see impacting everybody, is that people don't know how to break down work. Everyone wants to rush to coding. Coding isn't the work. Coding is the implementation of the thing that we did from the work we've done. The work is deciding the right thing to code. And so if we operate under a just do what I mean, figure it out during development manner of doing coding, then what we wind up with is lack of direction. We're going to kind of make it up as we go along. The very first time I tried to help, try to figure out why we couldn't do continuous delivery. What is it? At the time, it was just trying to figure out CD. We bought copies of continuous delivery, and we were trying to figure out how to implement that. And I started doing surveys from the developers in my area and just ask them some questions. One of my favorites was, why can't we do test-driven development? And the answer I got back was that we can't do TDD because we don't really understand what we're building. We have some vague requirements and we're doing exploratory coding and kind of showing it to the product owner while we're coding it to see if it's what they really meant. And then when we're done, we'll go backfill tests, hopefully, if we have time. And that generates huge amounts of waste and churn. And that's where the defects are coming from. If we don't get the right feedback, then we're going to go and deliver that with no tests based off those requirements, and it's just going to be wrong. So when I had those conversations, and this was back in 6-7 years ago, I started digging around trying to figure it out. Now, they had, in the past a few years, run us all through Agile training, and we were all Agile transformation and all the capital A, capital T terribleness. But they never did anything beyond, hey, you need to break down stories if they're more than 13 points is like, I think, the thing I most remember. They never taught us about behavior-driven development, even though it was in their books that they were teaching us from. And I had to go and find behavior-driven development on my own. I wish I could come over to London and talk to Liz Keogh, because she was the source of knowledge I used back in the day to uncover this as the way to clear that impediment. How do we get to the point where we can test our code? And if you don't know about BDD, please focus on this, because not only does this give us clear communication between all the stakeholders of how things are going to work, but it also gets developers in the mindset of how do I test this? So BDD gives us, we start with clear business goals, right? So we have a user story here, but a user story is just a start of discussion. And we have the discussion. And we describe the different scenarios of how things should work in testable ways, very declarative ways, in plain English, simple, short, to the point. And doing that means that we can lay out the different things it should do and identify different batches of deliverables. So this here, I can break this down to multiple people working simultaneously on the story so that, one of the goals we have is stories that are delivered in less than 2 days, every story. But that means duration and not effort. If I've got a team of 5, I can put 2 or 3 developers on a story, breaking it down to the subtasks, using these tests to inform what changes need to be made to which service and how they're going to interoperate with each other, implement each one of these acceptance tests, and deliver that very fast as the developer with the biggest task. And each one of those could be delivered without the rest of them going, because they're going to be tested and we can code them in a way so they don't have to be activated until we're ready for the entire feature to be delivered, which gives us the tiny batches of work that we can then do test-driven development on and make sure our quality is better. It also allows us to get feedback and adjust. I didn't deliver that last scenario. I had a conversation with all the stakeholders, and we decided we didn't want it to work that way. We did it in a test on paper, and the thought experiment of, well, if it did this, how would that be, made this possible for us to spend a few minutes in a conversation spending, tens, maybe hundreds of dollars, instead of developing it and spending tens or hundreds of thousands of dollars. Now, all of this said, you can have a team do this, but only if they have ownership. I've heard a lot of people saying, we're going to hold teams accountable. Okay, great. You're going to hold them accountable to the thing that you own. That's not how you get teams to deliver well. Teams need ownership. And ownership means we have clear goals. We have the tools available to us to accomplish them, those physical tools and mental tools. We're also responsible for the outcomes, which means I don't do grenade-driven development and throw poor code over the wall for ops to support and fix. I'm responsible for things that break. I'm responsible for fixing those. You might have ops out there kind of helping inform things that might be breaking soon. SRE is a good pattern, but nobody should be fixing my code but my team. I also have the authority to improve those outcomes, that I can look at things and within the bounds of the things we have in place at our enterprise, our company, that I have the authority to say, we need to change this thing to improve those outcomes, even if it's re-architecting. Ownership is key. So we have to optimize for value delivery. We're not doing CD for CD's sake. We're not doing CD just because CD's cool or we want a Jenkins pipeline. We're doing it to get quality feedback. We need to relentlessly improve that feedback. Our primary goal is the pipeline is our product. We're shipping features down our pipeline, but we're improving constantly the feedback we're getting from that pipeline to inform the next goal. And we organize everything around communication. You have to have a team that has everything it needs within the team to deliver its capability. You have to have organizational communication focused on value delivery and not on functional silos. Communication is key, and the more communication gaps you have between idea to production, the more defects you'll have, because every single handoff in communication is going to generate a defect. So if our goal is delivering value instead of just coming to work, then we are going to fix everything in our organization that prevents value delivery. Everything is up for grabs, and nothing is sacred. So just to sum that up, ownership means that we're going to have teamwork. We're going to have teamwork because we as a team care about the outcomes, and we're not going to let anyone hanging, no man left behind. We will make sure that we have each other's backs and are helping each other if someone's struggling. We don't point fingers at each other. That teamwork is going to give us an improved time to detect. We're going to find out faster if we have problems, be able to fix it as a team, which is going to give us sooner, safer, happier delivery, which means that we'll be more relaxed, deliver smarter. We'll be delivering solutions that are more secure, more stable, that we'll trust, that we can point out problems when they happen, that we don't, hey, there's going to be a data breach if we do this. We shouldn't do that, and trust that we're going to be listened to. That's going to give us faster user feedback, and then this just keeps accelerating. And the thing that I've experienced from doing this is that the final thing that you get, and the one metric I can point to, if you're going to point to one metric, is pride. That the team is proud of what they do. And if you're proud of what you do when you come into work, you're going to want it to be good. When I was the last team I was on, before I left that team, I said, hey guys, I feel this. I want to know if you feel the same way. This is my application, and we let people use it, and we want it to be awesome. And they all agree that that's how they felt too. And that pride of work is so much better than trying to instill fear or a point at accountability. Pride. So just to leave you with this, outcomes are what's important, not outputs. Productivity is not how much we deliver. It's how well we support the end user, how well we're serving the customer. It's customer first, not feature factories. So hopefully that was useful. Here's how you can contact me. And I've got a series of blogs on Medium, blog posts called 5-Minute DevOps, which is just some short things. Generally, they're rants that have been cleaned up, but people have found value in them. So hopefully they help.